Okay, well, hello everybody, and welcome to this Atmos UAV webinar, an introduction to Marlyn. I'm here at our base in Leiden in the Netherlands, and firstly, I want to thank you for taking the time out to join us for this webinar. So over today, we're going to be giving you a bit of an introduction into our Marlyn VTOL surveying drone. And you can see on this slide, underneath Introduction to Marlyn, it says easy to use, wind resistant, and accurate. And this is what I'm going to be aiming to prove to you over the course of today, that with our Marlyn VTOL surveying drone, you get a drone that is easy to use, that is wind resistant, and it is accurate. So just to go over a little bit on how the webinar works, you'll see that down the bottom of your screen on Zoom, if you're watching us through Zoom, you'll have things like the raise hand button, you'll have the Q&A button, and if you want to bring something up in the Q&A, you can write it in that chat box just there. So to give you a bit of an overview of the plan for today, the whole of this webinar is built around a live demonstration. So firstly, we'll be giving you a little bit of an introduction to Marlyn, telling you about the capabilities, some of the features, and then some of the benefits that you get as a user of Marlyn. After that, we're going to be putting you straight into a live demo experience with Marlyn. So we're going to be going out into the field on a pre-recorded demo and taking you through everything you need to know about flying Marlyn, from flight planning, through the checklist, through to the flight, takeoff, and landing itself. After that, we're going to look at some example data. And then after that, if you have any questions remaining, we're going to have a little bit of a Q&A session. Now, in terms of signups, there's over 300 attendees here. So we may not get through all of your questions in time, but rest assured, whatever you put into that QA box will be answered. If not on the webinar, then afterwards. Now, also before the webinar, we asked you guys about what you wanted to see and what your experience was. There was such an amazing variety of different levels of experience. So what we're going to be doing for this webinar is giving you a little about a lot of different things, rather than doing a deep dive into any one individual subject. What we're going to be then doing in the coming weeks and months is doing more webinars where we go a little bit more in depth into certain topics like post-processing and other things like that. And actually, we'll be asking for your feedback at the end of the webinar on what kind of things you want to see in future webinars. So firstly, I just want to cover a little bit about why we exist as a company. So what I was talking to you about before, about being easy to use and wind resistant and accurate, that's about what we do. Why we do what we do is, firstly, Atmos UAV exists to advance technology forward. We do that to empower industry to plan the future with precision, and then therefore being able to manage our precious environmental resources. So if you're the kind of person who believes in innovation, who believes in planning with precision and has that environmental conscience, then we really do have the product for you. Now, how can we advance technology? Let's probe that a little bit. So first, let's look at the state of current technology. Now, on the left there, you can see a multi-rotor drone. And I know a lot of you guys are actually multi-rotor drone users yourselves. Now, these came onto the market and revolutionized surveying. They offered speed and data coverage like had never been seen before. So companies like DJI and Unique were able to bring out easy-to-use drones that had some quite good sensors on them as well. But the big Achilles heel of these multi-rotor drones is that they can't really cover big areas because these propellers take most of the battery just keeping the drone in the air, which is not too efficient. So then around 2013, fixed-wing drones like the one in yellow that you see on the right-hand side came out. Now, these were able to cover much, much larger areas because the wings are essentially lifting the drone into the air and they don't have to use the batteries just to keep the drone in flight. The big weakness of these first, what they call fixed-wing drones, was that they had to be hand-launched into the air. And when they come into land, they kind of do a controlled crash. So they come down into land and do a landing on their belly. So you have to have a big open wide area. And also you have to put up with a general degradation of the drone itself as you do more and more landings. And so those of you who are users of current belly landing fixed wing drones will know how your heart rate tends to double every time your drone comes into land. So in order to be a viable tool for surveyors, drones therefore have to be easy to use and also accurate. So the task becomes, how do you remove the deficiencies of these drones and combine the plus points of those? So taking that into account, our founders 5 years ago developed the Marlyn VTOL drone. So what is a VTOL drone? A VTOL drone is something that combines the plus points of multi-rotor and fixed-wing drones and eliminates the deficiencies. So you get the flexibility of taking off and landing anywhere you like, the same as a multi-copter, but there's no barrier of small area coverage. So you multi-rotor users will be used to taking mountains of batteries out into the field and also just taking many, many days to accomplish reasonably small areas. Also, you get the ease of use of a fixed-wing drone, except you don't have to worry about the belly landings. Marlyn takes off and lands vertically and then transitions herself into that airplane mode. So you don't have to worry about damage for the drone. You don't have to worry about being really close to the propeller when you're throwing it into the air. It really does make it a lot easier to use in terms of fixed-wing drones. What's more is we can carry up to 42 megapixels in our sensors, meaning that the data that you get out of the drone is much more accurate as well. But I'll be discussing payloads in just a little bit. Now, ultimately, this ease of use, this wind resistance and accuracy empowers those in industry to plan with precision and manage the environment. So what are the benefits that you get as a Marlyn user? Well, firstly, in terms of ease of use, you get operation from any 2x2 meter area. That's the benefit of being able to take off vertically. Then after you take off vertically in helicopter mode and you transition into airplane mode, you get up to a 50-minute flight time. Now, in terms of flight area, that means about 100 to 150 hectares per flight at a 1 to 1.5 centimeter GSD. Now, a question that we got a lot in advance of this webinar as well is, what is the difference between Marlyn and some of the other VTOL drones that you get out there on the market? And the answer is this third point that you can see here, which is wind resistance. So right here in Holland, we are located right next to the North Sea, our main testing field where we develop the drone and also test all our delivery drones. Gets wind above 30 kilometers an hour almost every day of the week. So therefore, if we didn't have a good wind resistance, we could never fly. So with Marlyn, you get the ability to take off and land in up to 45 kilometers per hour of wind. When you get into airplane mode and you start surveying, that means you can fly in up to 55 kilometers an hour of wind. So if you're in coastal surveying or if you're in a particularly windy country, this can mean that you get up to 30% more days every month that you're able to survey. Think about what difference that could make to you in terms of your return on investment. Now, on top of ease of use and wind resistance, you also get accuracy with Marlyn. With a 42 megapixel full frame camera, you can get imagery as low as 1 centimeter. And also with our PPK module, you're able to get centimeter accuracy without the use of GCPs. Now, it's at this point, a lot of surveyors will step in and say, well, it's common that you should use at least 2 or 3 GCPs or at least checkpoints during your survey. And of course, that's possible as well. But for those who don't have the opportunity to place ground control points due to terrain or other reasons, PPK allows you to get down to those accuracies. Now, a quick chat about the payload options that are possible with Marlyn. This is how we're able to get to those accuracies and those GSDs. So our workhorse, our most sold sensor, is the one you can see on the left-hand side of your screen, and that's the Sony RX1 42 megapixel camera. So when combined with our Septentrio PPK module that you can see on the right-hand side, this is basically the Rolls-Royce of drone surveying out in the world at the moment. And so it's with that, you can get down to those centimeter level survey grade accuracies. On top of that, if you're someone who is maybe not in the surveying or mining industry and is more into agricultural or environmental or forestry applications, we also carry the MicaSense range of sensors. So we have the MicaSense Altum, which is a brand new sensor from MicaSense, which is a multispectral and thermal sensor. We have the MicaSense Red Edge, which is the entry-level multispectral sensor. And it's important to note as well that with both of these MicaSense sensors, we're able to use PPK. So not all VTOL surveying drones will allow you to use PPK at the same time as your multispectral sensors, while also using the downwelling light sensor that comes with those multispectral drones, multispectral sensors, I should say. And so we are able, if you're someone who's wanting to get really fine accuracies with your multispectral data, you're able to do that with a Marlyn. It's worth noting as well that all of our sensors are in-field swappable. So if you want to do an RGB survey and follow that right up with a multispectral survey, you're able to take out the payload module within Marlyn and exchange that in the field. It's also worth noting that our PPK module is upgradable. So all of our drones are sold with the PPK hardware, but if perhaps the return on investment doesn't work for you at that time and you want to go without PPK, all it takes later on to get a PPK-enabled drone is for us to send you a couple of USB sticks, and that upgrades your Marlyn to a PPK-enabled drone. A few people asked me as well if they were able to implement their own payloads. So if you have some payloads that aren't there on the screen, that's not possible at the moment. But trust me when we say that the survey-grade data that you get from these is going to be great for your customers. Now, I'm just going to touch a little bit quickly on Marlyn's flight dynamics and how she works, because this is also a question that I got from a lot of you guys. How does Marlyn work? How does the VTOL flight dynamics work? So, as you can see here, Marlyn takes off in helicopter mode. So she takes off from any 2x2 area and climbs to a predetermined altitude, usually 50, 60, 70 meters. At this point, she's going to transition into airplane mode and then fly up to her mapping altitude, which is usually 100, 120 meters. And then she's going to accomplish her mission. And at that point, she's going to fly back home. When she does that, Marlyn does a few circles, like corkscrews above the home point to descend to the transition altitude. And then she transitions back into helicopter mode, positions to the home point, and then comes back down to land. Now, at this point, 20 meters above the ground, Marlyn actually switches into manual control. So we have a remote control that we provide with each Marlyn, and that allows you to guide Marlyn into landing. I'll be going into that a little bit later when we jump into our virtual demo. Now, also what I'm going to do right now is I'm just going to give you a little bit of an insight into flight planning. I'm going to open up our MarLynk software and then just go through what it's like to plan a flight with Marlyn. Okay, so on your screen now, you will see the home page, basically the opening page of our flight planning software. So this is called MarLynk. It's been completely developed by us in-house, and it's used for your flight planning. It's used for the pre-flight checklist. It's used for your in-flight telemetry, and also some small operations after the flight. So just going to quickly run through planning a flight. So firstly, I'll just zoom into the area which I'm located at. Just going to zoom out to where we're at, which is right here, which is an old naval airbase here in the Netherlands. And so firstly, the thing you're going to want to do is select the right camera. Say I'm using the Sony RX1. And then we can select our transition altitudes from helicopter to airplane mode, our mapping altitude, which is of course corresponding to the GSD. So you can see a 100-meter mapping altitude corresponds to a GSD of 1.3 centimeters. And then we also set our home location. So let's just say we're going to be taking off from here. Next, I add my mapping region. And you can see I can add a corridor map, which is one of our new features. But for now, let's just say we're going to do a simple polygon. So let's just say we want to map this area of grass right here. All I need to do is click the points of my polygon on the screen, and the flight lines are automatically generated. Super easy. Then I can adjust the direction to make it a nice, efficient flight. And Bob's your uncle, your flight is planned. We can also make a cross-pattern flight if we want to get really good 3D info, if we're doing an urban area or something like that. We can also save that mapping region for use later. Finally, I'll just set my safety settings. So I have a geofence to allow Marlyn to stay within a predetermined area. I can set a return on low battery to whatever I like. Typically, we'll use 20. And finally, I can also set Marlyn to return home if she loses the radio link. But Marlyn's able to operate without the use of that radio link, so you don't have to worry about that during flight. And so all I need to do at this point is then save my flight plan onto the software. I can save my background maps, and from that point, I can go out into the field. Now, it's also worth noting that this map layers screen will also allow me to upload things like OpenStreetMap, WMTS, MB tiles. I can even load up elevation models or a previously saved flight plan or mapping region. So essentially from that point, you're ready to, once you've done your flight plan, you're ready to jump into the checklist. So I'm not connected to the drone right here, but what we're going to do is I'm going to pop back to our presentation. And then from here, what I'm going to do is we're going to go into our live demonstration. So essentially, this is going to take you into the position of being at one of our Marlyn demonstrations. So we're going to have 3 different camera angles throughout. There's going to be this wide angle that you can see here, which puts you in the position of someone who's an attendee at our demos. We have a roving camera, which goes into detail to show you some of the nuts and bolts of Marlyn. And also we have a mounted camera through a GoPro on the pilot, which is myself. And that gives you what it's like, a bit of perspective, what it's like to also be a pilot of Marlyn. And all the way as we go through the checklist, we go through the flight, we go through the landing, I'm going to be talking you through what we're doing at any given time. So firstly, what you can see on the screen here is everything that's included in a Marlyn bundle. So you can see Marlyn is packed into this really handy backpack. Marlyn collapses down into 3 different parts. So you can see the mid part and also the 2 wings, which it's still inside the backpack. Putting Marlyn together is super easy. All you need to do is take out the wing, you insert a couple of carbon rods, and then Marlyn safely locks in, Marlyn's wing, safely locks into the mid part. Now, the good thing about having Marlyn collapse down into this backpack is she's really easy to transport. If you happen to be going to an area where you don't have vehicle access or you need to go by commercial aircraft, then everything you need for that survey can pack down into that backpack. We've got a whole lot of pockets and little slots which carry everything you need, like your ground control station, your batteries, even space for things like base stations and other things like that. We've thought of it. So as the camera pans in here, you'll be able to see all of the equipment, the RC, the laptop, the radio module, all safely tucked away in there. It's also within the size to fit into standard commercial aircraft holds. So if you're traveling overseas, which I've done personally many times before to places like Australia, to Indonesia, to the USA, all you need to do is drop it off at the airport. And then you take your flight and it comes trundling down the baggage carousel at the end of your flight. It's really, really easy. And so now you can see Marlyn is assembled and is ready for flight. The next thing you can do is you can insert or put Marlyn's insert there into the backpack. And then from there, we're going to set up our ground station. And so Marlyn's ground station is really easy to set up. It's just a laptop and a radio module. The laptop is the one thing you'll see today that isn't included, but we run on Windows software. So this is the same software as what you'll use for your base stations or your other survey equipment. So you don't need to take any extra tablets or laptops in the field. You can see what I did there is just plugged in the radio module to the USB slot onto the tablet or onto the laptop. And then it's just a case of setting up your software and then you're away to go. Also included in the bundle is the full drone, the batteries. We include some basic spares as well. We also have a separate Pally case, especially good if you're flying and you have to pack the batteries into a separate case. A question we get a lot is our battery allowance within the amount that you can carry on a plane? That is correct. You are able to carry our batteries on a plane as we are 99.9 watt hours. And so there's no issues there. Before we fly, I also just do a last check of our altitudes, that I have sufficient clearance to the surrounding objects, and also just do a quick check of our safety settings as well. I think my video is running. And so then it's just a matter of opening up our little bits of software and going into the checklist. So this checklist has just been brought out and it's designed to be super easy to use. So all you need to do is just follow the simple on-screen instructions, and Marlyn will be therefore ensured to firstly be safe on her flight, and secondly be assured of doing a good survey. We check things like the GPS and the camera to make sure you don't come back with bad data. So what I'm doing here is just putting the batteries in. So Marlyn's batteries are dual redundant. I'll just quickly pause here and just give you a little walkthrough of what you can see inside Marlyn. So firstly here, what I'm outlining with this red dot is our payload module. So this is a complete module which contains the camera. And this is what you take out of the drone to swap in for a multispectral camera or any other sensor. There's no weight balancing or anything that you need to do. It's just simply take out one module and put in the next one and you're good to go. Just down here is where you insert the batteries. There's two batteries. They're dual redundant, which means that if one battery goes out, the other battery is on a separate power circuit. So it's going to take the drone back home. On the left of the batteries, you can just see in black is our autopilot. And then on the right in silver is our PPK module. So to insert the batteries is really simple. You just lock them in and then push to the end, and then Marlyn, the battery will click in. And once we've done that, there is power only to the autopilot. So the propellers and the motors are safe. So there's no risk to you as a user for being around the drone. Now, as you can see on the screen, there are different buttons there, which some are orange, some are red, some are blue. So the checklist is designed to be intuitive such that if your screen is all blue, then you're able to move forward. And orange, like you have here, is a warning. So in this case, it's telling me that my laptop battery only has 40 minutes left, so it's good to check or recharge. And anything red will prevent us from moving forward. So it's really super intuitive. What I'm doing here is grabbing the remote control and just checking that I have a good connection. So our remote control, as I mentioned before, is only used as a backup and also during that last 20 meters of landing. So anyone who's controlled a DJI, it's exactly the same as that. You just control the throttle and the GPS position, and then everything else is done by the drone. All of the rest of the flight, aside from that 20 meters of landing, is completely autonomous. So you don't have to worry, you don't need pilot skills or anything like that. Marlyn does most of the flight herself, and then just the last little bit for safety. What we're doing here is Marlyn is running a check of the camera. So the camera is going to take a few photos by itself. And then from there, we'll be verifying if the camera is working. It also gives you a readout of whether you have sufficient memory in your SD card. And that way you can be sure that when you come back from your survey, you've got the photos that you need. You don't have any nasty surprises after you get all the way back to the office and you're processing your data and you realize that the camera wasn't working. So that's the advantage of having this pre-flight checklist is any issues which can come up with drones, you discover them before the flight while you're in the field and the drone's on the ground. Now I've just placed Marlyn into her takeoff position. So the takeoff position is basically a position which is clear of other objects. It is facing the camera into the wind, as Marlyn needs to transition in helicopter mode into the wind. And finally, not on any big puddles of standing water. What I'm then checking right now is the landing feet switches. So these are switches positioned underneath the main helicopter motors. And what they do is they detect the second that Marlyn hits the ground and they turn all the motors off. Some of you who have used other drones may have noticed that when you hit the ground, you can get bouncing, or you can get the drone skidding or even falling over. But with this feature, it means that as soon as Marlyn hits the ground, the drone is stationary and you don't have to worry about any damage to the drone. And so we do a check of these to make sure they're all working correctly before we take off and also we come back to land. In this check, we're just checking the internal compass of the drone, the heading, to make sure that it's what it is in the drone is the same as what we have in real life. Now we upload the flight plan to Marlyn's autopilot. So this is the flight plan that we just generated. And what we then do is load that to the autopilot. And from this point, Marlyn is completely independent. She doesn't need any link with the ground station in order to fly. The entire flight plan is saved in the autopilot, so you can move forward from there. Now, we're at this point turning on the power channels, and from this point, the propellers are live. One of the last checks we do is what you can see here is Marlyn's going to do a little dance and is going to move all of her wing surfaces in order to check that everything is working correctly. So if these wing surfaces are able to move over their complete range of motion and then reset back to the neutral point, we're happy and we can move forward. And again, it's about spotting any issues before you get off the ground, which is why we do these checks. The final check that we do is we do a check of the motors. And in this check, I use the RC to turn the motors on. And then Marlyn's going to check herself that everything's running correctly. She's going to check the motors, she's going to check the propellers, and then in the software, you will get a verification that the motors are okay. And then from this point, we are doing our final little checks before we take off. So you can get yourself ready. You're about to see Marlyn take off and go into her flight. So I put the buttons into the right position on the RC, and then Marlyn will take off. So at this point, Marlyn's going to climb to her predetermined altitude, which is 60 meters. And at that point, she's going to transition into the wind and then fly off to her mapping region. And so at this point, after the transition, she's going to climb from her transition altitude to the mapping altitude. And then she's going to do her 4 mapping lines, nice and easy. Now, while Marlyn's in the air, I'm also going to answer a few of the questions that we got before the webinar. So some people were asking why we're able to get such a high wind resistance. So what is the feature that you have on Marlyn that other drones simply don't have? Well, there's a few different features. Firstly is the fact that we have 4 rotors in action during that takeoff and landing. So those of you who are DJI users will know that when you have 4 rotors, you have the full range of control in all 6 degrees of freedom. If you were to go out with your DJI and say, take 2 of those propellers away, you would have trouble controlling the drone. And that therefore means that with our 4 rotors, we're able to fly, take off and land in quite high wind conditions. The other reason is because we have a nice big stable tail fin, we have quite a lot of aerodynamic stability when the drone's in the air. And when you combine that with the fact that we have a motor at the end of each wing, we're able to yaw the drone into the direction of the wind. And what that means is that when Marlyn's flying in a crosswind, she doesn't need to tilt her wings at all. She can have the camera pointed straight down whilst the drone is pointing into the wind. And that's great for you as a surveyor because you don't have to take into account any additional overlap or anything like that. A few other people were asking me about some of the extremes that Marlyn's flown in. The coldest that Marlyn's ever flown in is minus 17 degrees in Canada, doing some surveys on the oil sands up there. The hottest that Marlyn's ever flown is just under 40 degrees centigrade, which is in the deserts of Australia. And it's important to note that no modifications needed to be made to Marlyn to do either of those flights. Essentially, the same Marlyn that took off in Australia could also perform just as well down in Canada. Probably the biggest test that we had for Marlyn was in Ecuador. We were flying at 5,000 meters above sea level. And the winds were about 40 kilometers per hour. And we had 1 square kilometer, 100 hectares to survey in a single flight. And the temperature was about 5 degrees, just over 5 degrees centigrade. And we were able to accomplish that survey, again, with the same Marlyn, without any modifications. And so that's the good thing about Marlyn's design, and she's quite robust. She's able to cope with quite extreme conditions. So what you would have seen on the screen just now as well is Marlyn has finished her mapping region and is now going to come back to the home point. And you'll recall from before, what happens is Marlyn comes back to the home point at the same altitude as the mapping, so at the mapping altitude. Then she's going to corkscrew downwards until she gets to the transition altitude. And then she's going to transition into helicopter mode into the wind. So during the flight, Marlyn has been guessing and estimating the wind direction. And so without any user input, she's able to automatically transition into the wind. Now, some cheaper VTOL drones will require you to manually set that wind direction, which is quite dangerous. Firstly, because the wind can change. And secondly, because the wind at altitude can sometimes be in a different strength and direction. So here she goes. She's going to do a transition now. And now she's transitioned into helicopter mode. What's going to happen is Marlyn will descend down to 20 meters. And then once she's done that, she is going to pass over to manual control. Now, there is no time pressure here. Essentially, what Marlyn does when she gets to 20 meters is just stays in her constant altitude and GPS position until the user picks up the RC and sends a signal to the drone by moving the throttle. And then it's at this point, you can move Marlyn in any direction. Now, the reason we do this is because landing areas are dynamic places. You can have cars, people, GPS movement, which can adjust that position. But here comes Marlyn in for a nice, stable landing. And you can see those motors have turned off immediately because of those landing switches that I showed you before. So at this point, you will turn off the power to Marlyn's motors, making her safe to approach. And then you can remove the batteries and put in some fresh ones and start another flight. You can start from, if you haven't finished the mapping region in question, you can start from your previous flight line, enabling you to create big mapping areas without having to make lots of little ones. Or you can pack Marlyn up, put her in the backpack, and make your way out of the cold surveying area back into the office. So once you've done with your flying, obviously you're going to want to do your geotagging. So especially if you've got PPK, one of the most important facets of working with Marlyn is working with the PPK module. So immediately after the flight, you can remove your data from the drone. So the camera the data comes from an SD card. The autopilot data comes from an SD card. The PPK data comes from a micro USB cable, which you plug into the drone. And then your base station data comes from whichever way you get your base station data. And you need all 4 of those data streams to work with GeoTagger. So what I'm going to do is just pop into my GeoTagger screen. So what you'll see here is our GeoTagger software, again developed by us in-house, a specialist software for Marlyn. So this software is super easy to use. It is literally just a case of selecting folders, and the software does the rest of the work for you. So what I'm going to do is I'm just going to bring up some data and show you what that interface is like. And all I need to do is bring up those 4 streams of data I was telling you about before, which is the images, the PPK logs, the autopilot logs, and the base station data. So I just select the folder that the images are located in. Then I select the folder that the PPK logs are located in. And you can see that it's marked that out on the map. And then finally, I select my autopilot logs. And then obviously I'm going to want some base station data to go with that as well, which I can just select. And what you can see on this map here is that all of the data which I've just brought up is represented on the map. Now, for you surveyors, look, you have a fantastically difficult job, but anyone can make mistakes, especially if it's a Monday morning or a Friday afternoon. And that's why we have the printout of everything on this map to make sure that there's no crossing of coordinate systems, that all of the right files have been selected, and it just takes out any little errors that might happen. So just to run you through what you can see on the screen, the gray track that you can see there is the track of the autopilot. So that is where Marlyn has flown at all points during the survey. The little black dots are the individual PPK timestamps. So if you have a track on one line with no PPK dots, then you'll know that for one reason or another, there isn't any PPK data for that line. Finally, this little green circle in the center there, that's the location of the base station. So you can use this to visually identify that everything is okay with your survey. Then you can select whether you want to operate it with cores as reference. You can operate it without any base station. You can operate it without any PPK processing, but we're just going to do it with our physical base station. You can see we have the Rhinex logs here. We don't need to put any info here because this is all coming from the Rhinex data. Then you can select an output directory. And then finally, choose whether to create a CSV or copy to each, the geotag to each image file. And at this point, if I was doing my processing, I would press geotag, but for the purposes of brevity, I'm going to move back to our presentation. So that's just a general little overview of how our GeoTagger software works. Now, to this point, I also promised you guys a use case of Marlyn. So this is a project which has recently been accomplished. It was accomplished in the Netherlands in an area of marshland up in the north of the country. This marshland is called the Kwelder. And essentially what the environmental agency is doing is they are taking an area of marshland and trying to make natural sea walls, natural dikes, by sedimentation. So they're letting the ocean carry all this sand and sediment in, and then as the water washes out, it leaves all that sand and sediment behind, which eventually grows the marshland. What it's then going to be used for is for planting vegetation and letting vegetation naturally grow. And the challenge is that they need to see how much sediment is being placed on this marshland. And that's a big challenge for all you guys who experience surveys, as you'll know, because everything on this marshland basically looks the same. So the differences that you're measuring with a drone are very minute. Now, the surveys in question first started with a DJI Phantom 4. Firstly, it took ages. It took, even just for 300 hectares, it took a few days to do the survey. And also by the end, because the sensor and the third-party RTK isn't as good, the data was not accurate enough in order to be able to see those fine little differences. And so they needed a drone to be able to cover a large area, to reach the survey area, which obviously you can't do in a vehicle onto marshland, and also be able to have enough data resolution and accuracy in order to map those marshlands. Thankfully, Marlyn was the tool for the job. So from this project, they were able to map the 307 hectares in a matter of a few hours rather than a few days. They were able to map with a GSD of 1.2 centimeters, and the accuracy was in all three directions underneath 2 centimeters in the absolute as well. The most important thing for them, though, was that with the data that they were able to generate, they could see the small indentations and trenches in the sand, that they needed to measure. So what you can actually see on this image on the left-hand side is this line is basically a cross-section, this red line of the marshland. And what you can see in blue is, in red is the data from February. And what you can see in blue is the data from October. And so you can see that the sediment is slowly building up on this marshland. And the difference between those layers is less than a centimeter. And so it takes a really accurate product to be able to get data like this. It's so accurate, in fact, you can see these two spikes here are in fact the fence poles, which you can see also mapped out on the DEM here as well. Now, if you're interested in getting this data yourself, we're going to get a poll up here now. So what you can do is indicate whether you're interested in receiving this data. We can send it to you as a .las point cloud, or we can send you the images and the CSV files so you can process it yourself. And we like to back up what we say. So we really want to show you guys the kind of accuracy that you can get with Marlyn. So if you indicate what you want, through the magic of modern technology, we'll be able to match that to your email. And then from there, we can send that data out to you so you can have a play around with it yourself. Now, a few people were asking me about as well where I can contact a local dealer. So we have Marlyns flying at the moment on 6 continents throughout the world. We have local distributors in every one of those continents. We're working with some of the largest drone service providers in the world. So Cyberhawk, who's the 3rd largest DSP, is currently using Marlyn in Scotland to map some of their electrical grids, and is also expanding to the USA as well. We're also working with CGR, one of the largest renewable energy companies in the world, to help them set up their wind turbine farms all around the world. Some of you may be looking at this map as well and thinking, oh, my country doesn't have a reseller. What actually we're doing is we're in conversation with resellers all across the world. So you can deal with us direct, or we can also put you in touch with some of the people that we're dealing with. Or if you are a reseller yourself and you see a blank spot on the map which corresponds to where you are, also feel free to get in touch, jump onto atmosuav.com, and we will happily start the discussion. So I promised at the start to show you how with Marlyn you can get ease of use and wind resistance and accuracy. So just to recap, the ease of use of Marlyn comes from our intuitive software. You've seen the flight planning, you've seen the checklist. With fully autonomous flights, so you don't need to be a pilot in order to fly Marlyn. It's very, very easy to use. Finally, you can have operation from anywhere. You can take the backpack into the middle of a marshland, launch Marlyn. You don't need an internet connection. You don't need a connection by radio to the aircraft. She really is very, very easy to operate from absolutely anywhere. Wind resistance, you can take off in 45 kilometers an hour of wind, more than any other VTOL surveying drone. And then when you get up to altitude, you can fly in up to 55 kilometers an hour of wind. And that's going to give you up to 30% more flying days. You can also get as good as 1 centimeter accuracy across up to 150 hectares per flight with none to very few GCPs. So if you're the kind of person passionate about the latest technology, you're passionate about planning with precision and managing the environment, then Marlyn really is the product for you. So this is what I wanted to show you guys. And now what I want to move into is our question and answer session. But firstly, what we are really interested in is also hearing about your surveying stories. So for the last hour or so, I've been talking to you about everything to do with Marlyn. But a great next step that I want to get you guys into as well is to set an appointment with us. And what we can then do is talk a little bit about your surveying experiences and some of the problems that you might be having, and maybe see if we can find a nice solution there as well. So what my colleague's going to do is we're going to throw up a second poll, And what you can do if you're interested in perhaps just having a chat, maybe seeing a private demonstration, we can also do private demonstrations, or anything like that, we can also put you in touch with our resellers. Feel free to indicate it there, and we can happily look after you as well. You can also contact my email there at james@atmosuav.com. So what I'm going to do, I'm going to dive into some of these questions here. I'll just bring them up. Okay, so we have a question of, could you explain the benefits of PPK versus RTK? That's a good question, actually. So RTK is one of the first very accurate ways that drones were able to get very accurate data. The main difference between them is that obviously RTK needs a constant connection to the drone while the drone's in the air, whereas PPK, all the processing is done after the flight. The benefit of RTK is obviously that your data is instant. You have your corrected data immediately after the flight, whereas with PPK, you have to do that post-processing step, that geotagging step. The good thing about PPK though is that if the data goes out for whatever reason, if you're not relying on a connection between the drone and the ground control station, because if you're using RTK and you lose that connection, then your data is gone. You have to do the flight again. Also with PPK, you have the advantage of being able to process both forwards and backwards. And so therefore the data that you actually get out of it is much more accurate as a result. Another question, is it possible to continue the mission after switching the batteries? The Marlyn to continue to fly from the last point where the low battery alert turned on. So this is a good question as well. That is entirely possible. So we have a continue from previous function. And basically with that, you're able to set a large flight area. So say your flight area is 5 square kilometers. You're able to just make that one flight plan. You can fly as many lines as possible within there until the auto return to home comes on from the low batteries. And then as soon as you land, there'll be a pop-up that comes onto the MarLynk screen, which is, do you want to continue your previous flight plan? And at that point, you just click yes. And then once you put the batteries back in, you just redo the checklist and you can continue that same flight plan. So it enables you to cover those large areas without having to set multiple flight plans. Can you give us an idea about the price of the drone Marlyn? So that depends on the accessories and the sensors and things like that. Generally speaking, what you can expect to pay is between 25 and 30,000 euros. And yeah, as I mentioned, that's going to depend on what sensor package and PPK and things you go for. Another question, I realize this is a strange question, but what are the wings made of? Will it float if it falls in the water? All my flights will be over water. So our wings and body are made of EPP. And it's actually milled EPP, which you're right, is a kind of foam. Will it float if it falls in the water? I'm not sure. We haven't tried. It's something that we don't want to try, I suppose, but it is, to answer your question, it is some kind of foam, and it would be feasible that it could float in the water. Okay. I see. So can Marlyn resume the flight plan after the operator has taken over flight control temporarily? So essentially the operator doesn't take over flight control at any time. So in terms of safety features, we have an emergency return to home. And that is if there's a bird of prey or something or a helicopter which has come into your area, you can trigger the return to home, and it's going to bring Marlyn home on the normal sequence. At that point, Marlyn's going to land, and then you can restart the start from previous function. The birds of prey, I think, are okay with Marlyn because she's quite large and also quite loud. We haven't had any problems with birds of prey yet. I was personally in Australia with our old Australian distributor, and we counted 16 eagles who were flying around Marlyn, and none of them went in for the kill like you typically get with smaller drones. And then as soon as Marlyn transitioned and turned her main helicopter motors on, they all got scared off because it does make a bit of noise when that happens. Is it called Marlyn or MarLynk? So the software is called MarLynk. So that's the flight planning software that I ran through with you, the flight planning and flight operation software. Marlyn is the drone. What is the max coverage area in one flight using both batteries? So it again depends on the altitude at which you're flying. Most countries are going to restrict you to 120 meters. I'm not sure what country that you're coming from, but at 120 meters you can expect to cover anything between 100 to 150 hectares, and that's with a 1 point or anywhere between 1 to 1.5 centimeters GSD, and a 60% overlap. Okay, what else have we got? Do we consider how MarLynk works in a windy region like the Netherlands? Quite well. And so we actually flew yesterday, and then the winds were gusting possibly a little bit higher than 45 kilometers an hour. Indeed, we're based in the Netherlands. We're based near Leiden, near the North Sea. So it is, wind is something that we have to deal with as a fact of life. And so we're able to fly and take off and land and survey without too many issues in the wind. Even in terms of battery, we find that our battery consumption is almost the same, sometimes even less in windy conditions. This is because when the drone is in helicopter mode and the wind is coming against it, the wind is providing some lift to the wings, which means less work for the propellers. And so it makes our drone perhaps even more efficient when it comes to windy conditions. Okay, we're getting quite a few questions in here. Quite a few questions on how does it compare to other VTOLs such as Wingtra. So as I was mentioning, I suppose in a perhaps not so direct way during the webinar, the main difference that you'll get between us and Wingtra is to do with the flight dynamics. I mean, Wingtra, they carry the same sensors, they carry the same PPK module. We're both VTOL drones, so we share those advantages. Where the difference comes in is when conditions get windy. We obviously are able to take off and land with those 4 rotors, and that just provides so much more stability. It means that that you also have that control in 6 degrees of freedom, which is also why we don't need to rocket off the ground and then also rocket back with, especially in windy conditions. So that's what we're able to provide. I think also when it comes to PPK, it's not possible with Wingtra to use the multispectral sensors. But yeah, aside from that, the differences are somewhat minimal. I think it was best described in one sentence by one of our USA partners who had previously used Wingtra before he used Marlyn, and he simply described it as a more stable Wingtra. Would be my one sentence answer. Okay. So I think there's quite a few still open, quite a few open questions still, but I think in the interests of brevity, we can wrap it up. Thank you very much for everyone who has joined us today and has taken the time to find out a little bit about Marlyn. For those questions that we didn't get to, don't worry about it. We are going to contact every single one of you personally to make sure that your question gets answered. Like I said, for those of you who have indicated that you're interested in a data set or interested in a chat or private chat perhaps, then we'll also get in touch with you and set a nice time to talk a little bit about your use case and how we can help out. So thanks a lot for joining, guys, and we hope to speak to all of you again very, very soon.